to kind of shorten our response times in the future. All right, so with that, I'm going to hand it off to my teammate Mo. Thank you very much.
Thanks a lot, Kiva. Good morning, everyone. As Kiva just mentioned, we keep focusing on the generative AI in this sprint and improve our Anika board and summarization tool. Go back to share my screen. Okay. So we learned how the summarization tool worked from Cutter and tried to run by ourselves. However, I realized that it won't work when connected to my own Azure OpenAI service, but the shared Anika Lab one. Then I spent a little bit time on figuring out what was the magic behind this, and find that the module's deployment name was hard-coded in the application code. If the deployed module in Azure is named differently than code specified, you cannot connect even though you have the correct endpoint and key. To make it portable, an additional config item is introduced to make the summarization tool compatible with any deployed OpenAI services. In addition, it also allows the app to connect to other modules like GPT-4. There are still remaining enhancement needed, such as specifying token limits and estimating costs based on selection. Ray, Carter, and I will have further discussion to address them. In this sprint, Josh and I also made a great progress with the Anika bot. As of last sprint, we have the generic OpenAI-based chatbot up and running and make it deployable to both Azure and AWS with automation. However, to meet the multi-cloud requirement, we feel hesitant to apply cloud-native design. So starting from this sprint, we switch back to AWS technical stack and modernize the application from day one. So the first Docker container-based bot is easier to port to different platform, but I'm afraid it requires Azure App Service or some equivalent service to provision, which contribute to our build that our management team may dislike. So our new AWS serverless bot does not involve any provision services. The front-end resource is stored in S3 bucket and connect to Lambda function-based API through API gateway. So let me switch to my cloud formation. And as you can see, the created resource only include some IAM role, the Lambda function, some log stuff, the API gateway, S3 bucket. That's it. So only we have those like management tool and the storage. So we don't have like EC2 or EKS or ECS created as before. So switch back to PPT. So the Bedrock and the Bedrock and OpenSearch, they play the same role as OpenAI and Cognitive Search do in Azure, or I should call it Azure AI service today. So the Bedrock looks like this. Okay, so you can just pick up the modules you like. We have the Amazon provided one, but we also have some other modules from different vendors. So when the activity drop during the weekend, so our hosting costs will be very close to zero without any like scaling effort required. Josh will present a live demo and explain how the new knowledge is ingested soon. But I do want to highlight the event-driven design with this process. So we don't need to like schedule any syncing job to load new content. Instead, whenever a new file arrives in the watch folder, the backend function will get triggered and update a knowledge base accordingly. We don't like waste computing resources on reloading known content. Another benefit of our serverless backend is the microservice pattern. Each function can be, say, refactored and deployed individually without impacting each other, as long as the interface remains the same. So to make the code styling consistent, Josh and I try to develop in TypeScript and JavaScript end-to-end, but I would say it is not mandatory. So we do find that there are more references in Python rather than TypeScript. And whenever we want, we do have the flexibility to write new functions in a different programming language while leaving existing function as is and expecting them to work together. I think that's all I have for this print. Does anyone have any question? If not, let me pass over to Josh to explain more about the backend workflow about this chatbot and present a live demo. Thank you.
Josh, it looks like you might still be on mute.
Good catch, Ray. Thank you. Good morning, guys. Thank you, Mo. So Mo did a great job of explaining how the user gets to the large language model and is able to query. And so what I want to cover is our serverless backend and how we get the information that we want specific to the model so that it's then searchable by the user. So this diagram that I'm showing is an explanation of all of the different serverless components that we're using. When you have documents that you want uploaded to be searchable in the model, we'll store those in an S3 bucket. And then whenever we load a document in the S3 bucket that's compatible, our Lambda function will pull the document and chunk it into appropriate sizes. Those get shipped into the SQS, simple queue service, which then sends those chunks along to be turned into vector embeddings by our second Lambda function here. Our vector embeddings are then stored in OpenSearch, and OpenSearch is both the indexer and kind of the search that provides the information to the large language models. And Bedrock is kind of the host for all of those. As Mo mentioned, there are a bunch of different large language models that you can use on Amazon or AWS. And one of the things that we do want to do in the future is start to look at all of the different models available and see which ones perform the most consistently for the specific tasks that we're using. So let's take a look at the code base and just get an idea of where all this is coming from. As Mo mentioned, our code base is written in TypeScript, and then we have some of it that's actually converted over to JavaScript or Lambda functions. So this serverless.yaml file is the kind of the main configuration if you're to run this on a new account. All you really need to do is input that account specific information. And then when you deploy this, it will deploy those resources in the form of a CloudFormation stack onto that account. These handlers here are the different Lambda functions. The ones that I covered in my backend are the chunking Lambda function, which just takes that document, checks to make sure it's either PDF or TXT. Right now, we're just focusing on text, and then embeds or creates the vector embeddings. Let's look back. Let's go to the console. This is the S3 bucket where we store the documents that will then be searchable on our large language model. You can see this morning, I uploaded this simple deskduck.txt document at 9:22. And then if we go look at the Lambda function, this is the document chunking Lambda function. And you can see here on the logs that we have a successful run at 9:22. So that's great. We'll follow that along through the queue. And we can see that the queue has taken those chunks and our vector embedding. This is our vector embedding Lambda function. And we've got a success rate here that those also went through. And then those finally end up over at OpenSearch where they're indexed, and happy to see that that also worked out appropriately. So this is the Anika bot, and as Mo mentioned, it's statically hosted on S3. So we can ask it a question. And we get a good answer, and I can confirm that I do actually have a rubber duck that looks like a giraffe. So looks like the information is pretty valid here. Happy to see it. So that's the back end, and that's how we get all the way to the model. And what we're going to be working on in the next sprint, one of the things that we already started and are going to be continuing the effort on is adding PDF ingestion. One of the challenges to this project is we are writing in TypeScript and then it gets converted to JavaScript for our Lambda functions. And so there have been some kinks to work out as we've been adding packages to handle different functionalities. And then we also want to fully automate the deployment. So right now there are some manual steps that we have to do. I showed you that serverless.yaml file where we can put in some configurations. And we want to make it so that it's more seamless, so that really you only have to input information there. And then all of the resources get deployed and they also kind of get plugged into each other. So some S3 configuration, we need to make it so that the data access policy gets applied correctly, and then also working with Bedrock and SQS as well. So those will be our next focuses. Any questions for me? Great. I'll hand it off to Raza. Thank you.